Hello and welcome to the Anishinaabe History Podcast. I'm Chris Waite. Can understanding glaciers and genetics help us understand the earliest human inhabitation patterns of Turtle Island? What are glaciers? Glaciers are large bodies of ice that spread slowly outwards and downwards as a very viscous liquid due to gravity. Continent-sized glaciers such as the Laurentide ice sheet and the Cordilleran ice sheet covered the northern part of Turtle Island during the last ice age. At the maximum spread of the glaciers, what is now Canada used to be buried beneath 4 kilometers of ice. Glaciers are related to global sea levels almost directly. When glaciers melt, the water rises. When glaciers grow, the sea level drops. And when the mass of continental glaciers change, the tectonic plate upon which the glacier rests responds accordingly. In other words, the Earth itself rises and falls analogously to rising and falling sea levels. Continental glaciers have a similar pattern, growing and receding on a scale of thousands of years. Global sea levels have changed by at least 120 meters across many thousands of years. Entire continents such as Doggerland in Europe and Beringia between North America and Asia have either sunk beneath the water or have been swallowed up by it, depending on how you view things. As these changes have occurred over geological timescales, humans have lived along the waterways and have used them for transportation and as places of settlement. According to some estimates, 20,000 years ago, the northern half of North America was in the midst of an ice age. The last glacial maximum was when continental ice spread was at its fullest, and it is thought to have occurred from 24,000 to 18,000 years ago. There has been much debate throughout the past 2 centuries about these timelines, these sea levels, and about who the first people of Turtle Island were and when and how they got here. Unfortunately, there are a lot of misconceptions and outdated ideas concerning these topics that persist into the 21st century. The ice-free corridor hypothesis, the overkill hypothesis, and the Clovis first dogma have all been delegitimized, and yet remain as obstacles to fuller understanding of human geography and genetic spread. This episode is an attempt to clarify early human inhabitation dates and patterns in North America.
Humans are usually thought to have reached the Americas through this route, by around 15,000 years ago, expanding downwards along the coast or through an ice-free corridor in the interior. But this is far from a closed case. As we've learned in class, there are more than a couple of theories. Though disputed, the Bering Land Bridge theory, the longest-lasting theory about migration to the Americas, is based on an understanding that 15,000 years ago, Alaska and Siberia were connected by a narrow strip of land known as the Bering Land Bridge. It is thought that groups of hunter-gatherers followed game across this land bridge, from Russia into North America. When the sea levels rose again, the land bridge was lost, along with any archaeological evidence of the crossing.
That was a clip from a video meant for children in a classroom. It was posted onto YouTube in late 2020, and it has been viewed almost 30,000 times. The video graphics show humans entering North America 15,000 years ago. Unfortunately, that video graphic is incorrect, because there is evidence of human inhabitation on Turtle Island south of the glaciers long before that date. It's an example of how an unrefreshed idea can perpetuate misunderstanding instead of instilling knowledge. For example, in 2009, researchers published evidence that people were already living south of the Cordilleran ice sheet along what would become the Columbia River 16,000 years ago. Archaeologists call it late Upper Paleolithic occupation at Cooper's Ferry, Idaho, USA. Idaho is interesting because 16,000 years ago predates the opening of an ice-free corridor, if you believe that classroom video on YouTube. A more accurate answer depends on when the corridor existed and upon how much ice the corridor had, and if it was the only way humans arrived on Turtle Island. Idaho is also interesting because it is in the northwest portion of the United States along a section of the Rocky Mountains. During the Ice Age, the northern part of the Rocky Mountains was covered by a continental glacier called the Cordilleran Ice Sheet. Quote, "The Cordilleran Ice Sheet nucleated in the high mountains of British Columbia. Small mountain ice fields grew and valley glaciers advanced when climate deteriorated early during each glaciation. With continued cooling and an increase in precipitation, glaciers expanded and coalesced to form a more extensive cover of ice in mountains. The glaciers advanced out of the mountains and across plateaus and lowlands, eventually coalescing to form an ice sheet that covered most of British Columbia and adjacent areas. End quote. The authors of the previous quote provided schematic maps of the extent of glaciation at various intervals. According to their schematic, North America was basically ice-free 35,000 years ago. The ice was in advance 30,000 years ago. At 25,000 years ago, the edges of the Cordilleran and Laurentide ice sheets were basically touching. Then, by 18,000 years ago, virtually everything north of the Medicine Line was under hundreds of meters of ice. And then the ice retreated during a period of deglaciation. It is within, or rather at the end of this time frame, that humans supposedly entered for the first time into North America, south of the ice sheets. Washington State, Oregon, Montana, and Idaho are the adjacent areas mentioned in the quote. Interestingly, each of these states has evidence of Paleolithic occupation. How rapid was the deglaciation of the Cordilleran ice sheet? The same authors of the aforementioned quote, Clegg and Ward, stated the following, quote, most glacial cycles terminated with rapid climate warming. Deglaciation was characterized by complex frontal retreat in peripheral glaciated areas and by downwasting accompanied by widespread stagnation throughout the Cordilleran interior. The western periphery of the ice sheet became unstable due in part to the global rise in sea level that occurred at such times. The British Columbia continental shelf was rapidly freed of ice, as glaciers calved back into fjord heads and valleys. Frontal retreat also occurred elsewhere along the periphery of the ice sheet, for example in northern Washington and southern Yukon. The first areas to become ice-free were those near the periphery of the ice sheet, for example, British Columbia's continental shelf and the plateaus of the northwestern United States. Active glaciers probably persisted longest in high mountain valleys, but they may have coexisted with large masses of dead ice on the plateaus of the Cordilleran interior. In general, retreat in the interior proceeded from both southern and northern peripheral areas towards the center of the ice sheet. In detail, however, the pattern of retreat was complex, with uplands in each region becoming ice-free before adjacent valleys. End quote. Idaho, in the northwestern United States, is an interesting archaeological site not only because of its age at 16,000 years old, but also because the lithic style that was found there is similar to assemblages found in Paleolithic Japan. Quote, in Japan and Korea, Hakuhen Sentoki projectile points dating from 30,000 to 20,000 calibrated year BP are made by retouching the proximal end of a thick pointed blade. The eponymous bifacial stemmed point type, seen mainly in Japan from 16,000 to 13,000 calibrated year BP, was often made on macroflakes or blades with contracting bases and elaborative bifacial retouch. Regional variants include the Tachikawa type on Hokkaido, the Koshigasawa type on northern Honshu near the Sea of Japan, and the Yanagamata type in central and western Honshu. The Tachikawa type bears strong morphological similarities to the contracting margin stemmed point bases from LU3 at Cooper's Ferry. End quote. The distance from Idaho to Hokkaido is approximately 7,700 kilometers. Montana is also interesting. A man there named Darrell Dusty Crawford had his DNA traced back 55 generations with 99% accuracy, according to the article. 55 generations takes us back about 17,000 years. Crawford shares DNA with many other indigenous North Americans. He's from one haplogroup, mitochondrial DNA B2, out of many that are found on Turtle Island. Other haplogroups of interest to North American Indians include QM3, QM242, and CM130, which are considered to be founding Native American haplogroups. Montana also contains the only known Clovis culture burial. Clovis culture is the name given to a type of stone tool complex and the people who made these specialized tools for hunting megafauna such as mammoths and mastodons. The Clovis tool complex existed from about 13,250 years ago to about 12,850 years ago. It was not a long-lived culture. The Clovis tool complex disappears from the archaeological record around the same time as the extinction of the megafauna, which gave rise to the so-called overkill hypothesis. What is the overkill hypothesis? It was proposed in 1966 by a geoscientist who noticed in the radiocarbon data that megafauna disappeared from the record around 12,700 years ago, and that humans were in the region around the same time. Quote, "The idea that humans wiped out North America's giant mammals, or megafauna, is known as the overkill hypothesis. First proposed by geoscientist Paul Martin more than 40 years ago, it was inspired in part by advances in radiocarbon dating, which seemed to indicate an overlap between the arrival of the first humans in North America and the demise of the great mammals. But over the years, a number of archaeologists have challenged the idea on several grounds. For example, some researchers have argued that out of 36 animals that went extinct, only 2, the mammoth and the mastodon, show clear signs of having been hunted, such as cuts on their bones made by stone tools. Others have pointed to correlations between the timing of the extinctions and dramatic fluctuations in temperatures as the last ice age came to a halting close." End quote. Furthermore, in 2014, archaeologists at the University of Missouri compared databases containing megafaunal radiocarbon dates. They, quote, "compiled databases of radiocarbon dates from both megafaunal finds and Paleo-Indian sites for the Northeast, throwing out any dates whose reliability had been or could be questioned. This gave a final sample of 57 megafauna dates from 47 different sites and 25 Paleo-Indian dates from 22 sites. When the two databases were compared, it became clear that most of the megafauna had already disappeared before humans came on the scene, suggesting that the humans had little to do with their demise." End quote.
One of the really interesting features are the teeth. This is a tooth of a mammoth, and mammoths were grazers. So they ate off the ground, grasses, and you can see the plates they could grind away. Now, this is the tooth of a mastodon, and they're more cusp-like. In fact, some people refer to them as almost nipple-shaped. This guy was more of a browser, so he would twigs and more rough vegetation. Exactly. Another cool feature of their teeth is the number of teeth they had and how they lost them. So it was like an assembly line. They would have one tooth, they would grind away, they would lose a tooth, another one would come. After 6 sets, that was it. And there's the sad tale. They lived with their 6th set, and once the tooth wore out, they couldn't eat anymore, and they
died.
That's it.
That is sad.
Very sad.
Almost 13,000 years ago, in what is now south-central Montana, a very young child, about 1 or 2 years old, was interred and dusted with red ochre. It was a ceremonial burial. The burial remains, called Anzic I, have been radiocarbon dated to about 12,600 years ago, and are linked to the Clovis culture by associated lithic assemblages. DNA was extracted from the remains of Anzic I. The results were intriguing. Quote, "DNA testing of the Anzic boy showed Siberian ancestry. The testing also showed a close link to modern Native Americans. This includes those from Central and South America. The results support the idea that modern Native Americans come from Asian peoples who crossed the land bridge from Asia to North America." End quote. That's a very basic overview of the peopling of Turtle Island, but there is some truth to it. Crossing the land bridge makes it seem like a one-time, all-or-nothing event from the northwest and then southwards. What else did the DNA of the Anzic burial remains show? Genetic analysis showed that the boy's mitochondrial DNA haplogroup was D4H3A. That's the 5th genetic haplogroup found in Turtle Island humans that is of interest to the peopling of North America. That haplogroup is shared by modern Native Americans. I'll read what the researchers who studied the genome of Anzac Boy said in their article's abstract. Quote, "Here we report the genome sequence of a male infant, Anzac 1, recovered from the Anzac burial site in western Montana. The human bones date to 10,705 plus or minus 35 carbon-14 years before present, approximately 12,707 to 12,556 calendar years BP, and were directly associated with Clovis tools. We sequenced the genome to an average depth of 14.4x and show that the gene flow from the Siberian Upper Paleolithic Malta population into Native American ancestors is also shared by the Anzac 1 individual and thus happened before 12,600 years BP. We also show that the Anzac 1 individual is more closely related to all indigenous American populations than to any other group. Our data are compatible with the hypothesis that Anzac 1 belonged to a population directly ancestral to many contemporary Native Americans. Finally, we find evidence of a deep divergence in Native American populations that predates the Anzac 1 individual." End quote. The gene flow from Siberian into Native American ancestors happened long before 12,600 years ago. Furthermore, if Anzac Boy's mitochondrial DNA, haplogroup D4H3A, is also in South America, could this be evidence of a southern origin of the pre-Clovis inhabitants of North America? Remember, Idaho is interesting because there is evidence of human occupation along the Columbia River dated to 16,000 years ago. On a website regarding the peopling of North America, the following is stated, quote, "Another option is that a group with D4H3A moved south along the Pacific coast. A small subset of them turned back north into inland North America. Descendants of this small subset would then become part of Clovis culture in Montana." End quote. I think that there is truth in that statement. What I would add is that that group in Montana, approximately 12,600 years ago, was not the first group of people to arrive in that area. There were probably subsets of people breaking off into rivers and various overland explorations while others continued along the western coast of the Americas, and it occurred over many, many thousands of years. Researchers also studied Anzac 1's Y chromosome DNA. They discovered that the DNA was part of the QL54 branch, but not part of the QM3 branch. The QM3 genetic branch is common to over 80% of Native American male lineages, according to the authors of haplogroup.org. The QM3 haplogroup is also found in South Americans. When did QM3 and QL54 diverge? The divergence occurred about 15,000 years ago, according to geneticists. It has been determined that QM3 is a subclade of QL54, and that QL54 is a subclade of QM242. Haplogroup QM242 is found in Ojibwe people at a high rate, even though that haplogroup has been determined to have originated in south-central Siberia sometime between 32,000 and 17,000 years ago. Haplogroup QL54, which is a subclade of QM242, existed 20,000 years ago, and its place of origin was likely Beringia, most likely eastern Beringia. If L54 existed 20,000 years ago, and it is a subclade of QM242, then the haplogroup QM242 must be at least that old. An archaeological discovery along the Columbia River in North America called Kennewick Man contained QM3 DNA. Kennewick Man is the name given to the skeletal remains found along the banks of the Columbia River in Washington state. The bones were radiocarbon dated to about 9,000 years ago. Analysis revealed that the bones were genetically related to the modern Native Americans of that area, specifically the people of the Confederated Tribes of the Colville Reservation. I'll read what it says on Wikipedia. Quote, "In June 2015, The study team announced they had concluded their DNA analysis, finding that Kennewick man is closer to modern Native Americans than to any other population worldwide, and that genetic comparisons show continuity with Native North Americans. The same study confirmed the mitochondrial haplogroup X2A and the Y chromosome haplogroup QM3 of Kennewick man. Both lineages are found almost exclusively among modern Native Americans. End quote. I think that's 7 haplogroups I've mentioned as belonging to Native North Americans. Recall that QM3 is a subclade of QL54 and of QM242. What about Ojibwe DNA? Asking that question brings us to the 8th group I'm going to mention, haplogroup R1. Quote, haplogroup R1 is very common throughout all of Eurasia except East Asia and Southeast Asia. Its distribution is believed to be associated with the resettlement of Eurasia following the last glacial maximum. End quote. There was a population that went back across Beringia and back into Asia, but there were people who stayed on Turtle Island. Quote, the presence of haplogroup R1 among indigenous American groups is a matter of controversy. It is now the most common haplogroup after the various QM242, especially in North America in Ojibwe people at 79%, Chippewayan 62%, Seminole 50%, Cherokee 47%, Dogrib 40%, and Tohono O'odham 38%. End quote. Haplogroup QM242 is interesting. This haplogroup is considered as a founding haplogroup in Native Americans. It is interesting because this haplogroup likely developed in south-central Siberia in the Altai Mountains sometime between 17,000 and 32,000 years ago. If you take the average, then it's about 25,000 years ago that the QM242 haplogroup arose. But as I mentioned earlier, the QM242 haplogroup must be at least 20,000 years old if a subclade of that haplogroup is itself 20,000 years old. That changes the average, i.e. 20,000 plus 32,000 divided by 2, of the possible origin of QM242 to 26,000 years ago. If there were humans with haplogroup QL54 in North America 16,000 years ago, does that mean that the QM242 haplogroup is closer to 30,000 years old than to 17,000 years old? Remember, the man in Montana's DNA showed 55 generations, or 17,000 years, of genetic heritage. Were his ancestors still on Beringia or already in Montana when their haplogroup diverged from others? Genetic evidence shows that Kennewick man, haplogroup QM3, and Anzac boy, haplogroup L54, were not only ancestors to modern Native Americans in the Pacific Northwest, but also descendants of ancient Siberians and eastern Beringians. That's because haplogroup M3, Kennewick man, is a subclade of L54, Anzac boy, and L54 is a subclade to M242. Can the R1 haplogroup provide some more information? In the previous quote, it was stated that R1 was the most common haplogroup after QM242. It is important to note that R1 is a sibling clade to QM242, and that Ojibwe people's DNA has a high ratio of both the R1 and QM242 haplogroups. Quote, the origins of haplogroup R1 remain unclear. R is a direct descendant of haplogroup P1, and a sibling clade, therefore, of haplogroup QM242. No examples of the basal subclade R1' have yet been identified in living individuals or ancient remains. However, the parent clade R' was evidently present in Upper Paleolithic era individuals 24,000 years BP from the Malta-Beret culture in Siberia. The autosomal DNA of the Malta-Beret people is a part of a group known to scholars of population genetics as Ancient North Eurasians, ANE. The first major descendant haplogroups of R1', R1a, and R1b appeared subsequently in Mesolithic, Central Asia, and Eastern Europe, with genotypes derived, to varying degrees, from ancient North Eurasians." End quote. But is that all there is to the story? When did humans first arrive in North America, south of the continental glaciers? Where did they come from? A lot of evidence points to Eurasian progenitors along the Columbia River at least 16,000 years ago. That fact alone means we cannot take seriously claims of a Clovis first hypothesis, with its date of first North American inhabitation by humans around 13,000 years ago, because there's too much evidence that says otherwise. Nor can we take seriously claims of a singular ice-free corridor at such and such a date being the only route of human entry into the Americas. Again, there is just too much evidence from various scientific disciplines such as archaeology, genetics, and linguistics that indicates other routes of entry into the Americas. Beginning from various glacial termini, the further south you go, the more evidence there is for pre-Clovis and pre-corridor human inhabitation of Turtle Island. Did people travel north into an ice-free corridor?
What I'm trying to say here is that as we excavated through these deposits, I could almost predict what in the world we were going to find as we went deeper and deeper. Below the Folsom was Clovis, okay? And you don't find this much where you find a Folsom component overlying Clovis. I think this is probably the third locality with such a thing. We found Clovis bifaces with overshot flakes. We found Clovis bases and midsections. We found blades. We found flute flakes that came off of Clovis projectile points. And so we found enough of the Clovis assemblage to clearly tell us that Clovis was here. We continued to excavate, and lo and behold, what do we find? We continued to find additional artifacts in this zone of the floodplain deposits as we dug deeper and deeper. And this we dubbed the Buttermilk Creek Complex.
If Idaho is interesting, then Texas is tantalizing. That's because in Texas there are numerous archaeological sites of interest for learning about early human inhabitation of Turtle Island. There is the Deborah L. Friedkin site and the Galt site, both of which are near the headwaters of Buttermilk Creek. This area would have had a lot of resources necessary for survival: fresh water from springs, a variety of plants and animals for resources, as well as a chert stone outcrop from which to make tools. How old are these Texas sites? The current consensus, based on optically stimulated luminescence as a dating technique, is almost 16,000 years ago for an initial occupancy of the Buttermilk Creek area by humans. The Galt site along Buttermilk Creek is interesting because it contains Clovis as well as pre-Clovis artifacts. The pre-Clovis artifacts were dated to about 15,500 years ago, and the Clovis artifacts were dated to about 13,000 years ago. That's a difference of 2.5 millennia. What about White Sands, New Mexico? Fossilized footprints of humans have been found there and dated to approximately 23,000 years ago. Quote, "A multidisciplinary team of scientists recently announced the discovery of the oldest human footprints in North America. These fossilized prints were made between 23,000 and 21,000 years ago along the shores of an Ice Age lake that once filled the Tularosa Basin in south-central New Mexico in what is now White Sands National Park. This finding fundamentally changes the timeline on North American human habitation, turning back the clock of human arrival in the Americas nearly 10,000 years." End quote. If people were in New Mexico 23,000 years ago, that would give their descendants a couple of thousand years to get to Montana, Idaho, Washington State, Alberta, and Pennsylvania, all of which are places with sites dated to ages of at least 16,000 years old. In this case, a south to north progression of humans makes more sense than a north to south one. What about Topper, South Carolina? The site is recognized as Clovis due to the lithic material found there. The spot was likely settled because of its chert outcrop, similar to the site at Buttermilk Creek, Texas. While recognized as a Clovis site, Topper revealed literally deeper clues to human inhabitation along the Savannah River. That's because lithic tools have been found below the Clovis archaeological layer. Below, and therefore earlier than the Clovis layer, lithic artifacts have been found in the White Pleistocene alluvial sands layer, as well as the layer below that one called the Pleistocene Terrace. The Topper site has been dated to 50,000 years ago, not 15, 50. Quote, in their appraisal of the dating of Topper, Waters et al. Reported that it dated diachronously from minimally about 15,000 years BP to at least 50,000 or more years. The radiocarbon dating of the White Pleistocene alluvial sands deposit, with the cores farther up the terrace ranging from 25,330 BP to 38,810 BP, is the probable minimal age of the upper Pre-Clovis assemblage. That being the case, the beginning of the site as found in the Pleistocene Terrace would still be minimally about 50,000 years BP or more. A time span of 25,000 to 50,000 BP or longer is still a remarkable amount of time for a lithic technology to persist, at least by New World standards. The use of single-grain optically stimulated luminescence dating on these sediments will be necessary to try to date the beginning of human occupation at Topper. For now, it clearly dates well before the last glacial maximum, and joins other sites such as Pedraforada, Monteverde I, and Burnham in Oklahoma, all of which give strong hints that the peopling of the Americas had a much earlier beginning than the currently recognized late Pleistocene sites of North America, such as Meadowcroft Rock Shelter, Cactus Hill, and Friedkin, to name a few. End quote. So far, I've talked about Idaho, Montana, and Washington State, which are north of New Mexico, Texas, and South Carolina. But even further north of those sites is another one in Bow River Valley, Alberta, that has been dated conservatively to about 21,000 years ago. It could be as much as 25,000 years old. The Alberta site contains pre-Clovis lithic assemblages and is about 1,400 kilometers north of both Idaho and Montana. It is near the city of Calgary at a latitude of 51 degrees north. Quote, the suggested relative age of the stone tool assemblages is based on the chronostratigraphy of the quaternary deposits at both sites. Contextually, the earlier occupation episode is manifested by finds from Site 2, largely in a secondary context, originally distributed on top of the uppermost fluvial deposits subsequently buried by an early late Wisconsin Cordilleran till. The later settlement is documented by stone artifacts partly recorded in situ on the gravelly surface of the till below 24 meters of glacial Lake Calgary deposits. An approximate age circa 25,000 to 21,000 years BP and greater than 21,000 years BP respectively is suggested for the lithic artifact assemblages. The sedimentological and palynological data indicate a cool semi-arid forest steppe tundra interstadial climate during the occupation episodes. These, together with the cultural evidence itself, explicitly document ice-free conditions in southwestern Alberta prior and possibly shortly after the last glacial maximum. The cultural evidence from the investigated sites supports the concept of a pre-Clovis occupation of North America. End quote. If people were living in the Calgary area 25,000 years ago, were they related to the ancient Siberians that modern North American indigenous people are related to genetically via the R1 and QM242 haplogroups? Remember, the R1 haplogroup existed in the Altai Mountains of Siberia 25,000 years ago, and R1 and QM242 are sibling clades. It is unlikely that a group of people instantly teleported from central Siberia to southern Alberta, or vice versa, 25,000 years ago. Thus, if they were from Eurasia, then the R1 haplogroup is probably closer to 30,000 years old than to 26,000 years old. By comparison, Anzac Boy at about 13,000 years old and Kennewick Man at 9,000 years old are relatively recent. That leaves me with one question. Who were the ancestors of the Paleolithic South Carolinians? That's all for today's episode. Stay tuned for more episodes in the future. I'm Chris Waite, and this has been the Anishinaabe History Podcast.